Refining is a very important process. After extraction of the metal from the ore, it may contain some of the impurities which have to be removed for the proper usage of the metal. So the metal extracted by any method usually contains some impurities or maybe other metals present in the extracted metal. So for obtaining metals of high purity, there are several important methods which are used, which depends on difference in the properties of the metals and impurities, and by using those difference in the properties, the metal is purified and the contaminants are removed from the extracted metal. Those techniques are distillation, liquefaction, electrolysis, zone refining, chromatographic methods, and vapor phase refining. So here we are going to understand distillation, liquefaction, electrolysis, and chromatographic methods. First one is distillation. So it is a very useful technique for low boiling metals like zinc and mercury, and here the impure metal is evaporated to obtain pure metal as distillate. So here distillate means the remaining which is present after the distillation process, and during distillation the impurities get evaporated in the form of gas and they are removed, and the remaining solution in the distillation unit is nothing but a pure metal. Then second one is liquefaction. So the liquefaction is a method of purification for low melting metals like tin. So where the tin is made to flow from a sloping surface or a inclined surface, and here what happens is the higher melting impurities are left behind and low melting metal flows from the top to bottom of the inclined surface and it is collected, and by this way there is a separation of low melting metal from the high melting impurities, and this method is called as liquefaction. Then third one is electrolytic refining. So in this method, the impure metal is made as anode and a strip of same metal which is in the pure form is used as a cathode, and they are immersed in a suitable electrolytic bath containing soluble salts of the same metal. And this electrolytic refining works on the principle that the more basic metal remains in the solution and less basic ones goes to the anode mud. And here the anode mud means it is a waste which is produced during the electrolysis process. And this process also explained by the Gibbs energy equation and also the electrode potential. And we can represent the electrode reactions like this, that is where in the case of anode the metal gets ionized and it gets dissolved in the electrolytic solution, and in the case of cathode the metal ion which is present in the solution gets deposited on the cathode. We have to see the example of copper by electrolytic refining, where the copper is refined using an electrolytic method. Anodes are of impure copper and the pure copper strips are taken as the cathode. And here the electrolyte is nothing but a acidified copper sulfate solution, and the net result of the electrolysis process is nothing but the transfer of copper from anode to cathode, and at cathode we are getting the pure copper, and we can represent the reaction like this. That is anode. At the anode, the copper gets dissolved into the solution as a copper ion, and at cathode, the ions which are present in the solutions get deposited on the cathode, and in the cathode we are going to get the pure copper, which is scrapped from or taken out of the cathode by different methods, and we are getting the pure copper. And the impurities which are present in the blister copper are deposited as the anode mud, which contains some of the impurities like antimony, selenium, tellurium, silver, gold and platinum, which are having very high economic value. And by recovering these elements from the anode mud, we can have the cost which is employing for the electrolysis process. Then the last one is chromatographic methods. So this method is based on the principle that different components of a mixture are differently adsorbed on a adsorbent. So this adsorption on an adsorbent depends on different forces which are present in the compound and also the adsorbent. So the two, on the extent of adsorption on the adsorbent, we can separate different metals from the impurities. Here the mixture is put in a liquid or in a gaseous medium which is moved through the adsorbent. That means the metal which we want to purify is mixed or put in a liquid or gaseous medium, and it is made to move through a adsorbent. So the different components of the mixture or the liquid gets adsorbed at different levels on the column, and after the adsorption process, so we are going to remove those components by using suitable solvents which are called as elutants. Depending on the physical state of the moving medium and the adsorbent material, the chromatographic methods are given different names. Here, some of the examples for chromatographic methods are column chromatography, so which is a very useful purification method where we can purify the elements which are available in minute quantities and the impurities which are having similar chemical properties to that of the elements. And also, apart from the column chromatography, we have several other chromatographic techniques such as paper chromatography, gas chromatography, then high performance liquid chromatography, etc. So this is a diagram which is showing the column chromatographic method. So one is a industrial method or industrially used chromatographic setup, column chromatographic setup, and second one is a laboratory method. So if you observe the laboratory method, so you can find a column, so where the column is filled with a silica gel or alumina, so which is acting as a adsorbent, and from the top the mixture of components are added and elutant is passed. So in the second column you can observe the color bands, so which are of nothing but the separated components of the mixture, and they are removed by the elutants which are passed after the process. So this method is nothing but a chromatographic method where we can separate the different kinds of elements from the mixture.